Number 2. A rough plane is inclined to the horizontal at an angle alpha, where tan alpha is equal to 3/4. A small block, B, of mass 5 kg is held in equilibrium on the plane by a horizontal force of magnitude x newtons as shown in figure 1. The force acts in a vertical plane which contains a line of greater slope of the inclined plane. The block B is modelled as a particle. The magnitude of the normal reaction of the plane on B is 68.6 newtons. Using the model, part A, 1, find the magnitude of the frictional force acting on B. So first, we would label our diagram to show all the forces that we've been given in the question. So first, we've been given the mass as 5 kg, which means we have the force of the weight acting downwards, which would be 5g. To find the components which are parallel and perpendicular to this, we would resolve this as being 5g cosine alpha, and parallel to the plane, this would be 5g sine alpha. We then have the reaction force which will work on B going upwards, and that is 68.6 newtons. We then have the frictional force acting on B. However, because we do not know the direction, for now we can just put it going up the slope. And once we do our calculations, we will know what direction it's acting in. We then have the force X, and we would have to first find the component. Because this angle here is alpha, this would also be alpha, and therefore the component parallel to the plane would be X cosine alpha, and perpendicular to the plane we would have X sine alpha. We've then been given this value of tan alpha, which is 3/4. So if we draw a right-angled triangle, this is 3, this would be 4, which means our hypotenuse would be 5. We can therefore use this triangle to find values for sine alpha, which would be 3/5, and cosine alpha would be 4/5. We now need to find the magnitude of the frictional force acting on B. So first, we would start by resolving forces perpendicular to the plane, and we would be looking at these forces. So first we can do the upward force, which is 68.6, and this should be equal to the downward forces, which are 5g cosine alpha and x sine alpha. We can then substitute the values that we know. So we know that cosine alpha is 4/5 and sine alpha is 3/5. And the 5's would cancel, and we would therefore be left with 68.6 is equal to g times 4, which is 4g, and 3/5x. We can then minus the 4g, and we can use the value of g as 9.8, and this would be now equal to 3/5x. If we then divide by 3/5, this would give us the value of x, and if we put this into our calculators, x would be equal to 49 newtons. Because we've now found x, we can now resolve the forces parallel to the plane, and that would be these three forces. So we can write this as x cosine alpha plus our frictional force F is equal to the forces going to the left, which is just 5g sine alpha. If we now substitute the values we know, we can substitute cosine alpha as 4/5 plus F is equal to 5 times g. We can put 5 multiplied by our value of g, which is 9.8, and for sine alpha with 3/5. For x, because we found x in part A, we could also substitute that with 49. In order to find F, we would therefore have to take away the whole of the first term on the right-hand side. So we can write F is equal to 5 multiplied by 9.8 multiplied by 3/5, take away 49 times 4/5. And if we put that into our calculators, we will get F is equal to minus 9.8 newtons. And because the question is only asking for the magnitude, we will put F is equal to 9.8. Part A2 asks for the direction of the frictional force. Because in our diagram we put the frictional force going up the plane, however we got a negative value for it, that means according to our calculations, the frictional force is actually acting down the plane. So for part A2, we will just put down the plane. We are then told the horizontal force of magnitude x newtons is now removed and B moves down the plane. Given that the coefficient of friction between B and the plane is 0.5, part B says find the acceleration of B down the plane. So because x is now removed, we would now have to redraw this diagram and put in the values that we know. We already know the weight would be 5g, and the components of this parallel and perpendicular to the plane would also remain the same. So we can put those into the diagram first. Because the plane is sloping down, the particle would naturally move down the plane, which means the frictional force would therefore act in the opposite direction, which would be up the plane. There would now be a new reaction force working there, R, and we can therefore show the particle accelerating down the plane. So for part B, we would first resolve the forces perpendicular to the plane, and we can say R is equal to the downward force, which is 5g cosine alpha. We can put g as 9.8 and cosine alpha as 4/5. And if we work this out in our calculator, we will get our value of R as 39.2 newtons. We can now resolve the forces parallel to the plane. And because this particle is moving, we will use the formula force is equal to mass times acceleration. So to find the resultant force, we will say 5g sine alpha minus the frictional force is equal to the mass, which is 5, times the acceleration. We've also been told that the coefficient of friction is 0.5, and we know that F is equal to the coefficient of friction times R. So we can now replace our F with mu R. So when we write this equation, we will now write it as 5 times G, which is 9.8. We can replace sine alpha with 3/5, and we can replace F with mu R, and this would be equal to 5a. We can now also substitute the values for the coefficient, which is 0.5, and the reaction force, which we found, which is 39.2 newtons, and this is equal to 5a. If we work this out in the calculator, this would be equal to 49/5, and this is equal to 5a. If we divide both sides by 5, we will have 49/25 is equal to a, and therefore our acceleration is equal to 1.96 meters per second squared. And that is our final answer for part B.